Hi, this is Kavati Sridhar, Assistant Professor in EC Department at Mlritm College, Dundigal. Today, I'm going to explain Yagi-Uda Antenna and its design considerations. This is also called as the directional antenna, and it is invented by the Yagi and Uda. Professor Uda, this is designed by the Professor Uda, and after later it is translated into English by the Yagi. So that's why it is called as this antenna name it as Yagi and Uda. Okay. Commonly used for the very high frequencies and ultra high frequencies bands, high gain and good directivity. This antenna having the high gain, and it is used in the very high frequencies and ultra high frequencies. So it is having three parts in the antenna. One is reflector, another is driver element, and other one is the directors. The basic structure of this antenna, already I told you that is driven element, half wave dipole, and a reflector slightly longer than the dipole. The whatever the backside antenna is there, that is longer than the driven element. One more director is the parasitic element, which is after driven element. All elements mounted on a boom. That is like a array. Driven element, reflector, and directors. So now I will briefly explain what is the driven element and a reflector and a director. Only one active, that is called as the driven element. That means it is having the some feed element. Feed element means we are giving to the source to it. The next one is typically half wavelength long. So whatever the driven element is there, that is typically half wavelength long, connected to the transmission lines. Whatever the feed line is there, that is through the transmission line only. That means we are giving the source to the transmission line. And next one is reflector. This is placed behind the driven element. The parabolic, the Yagi-Uda antenna is having one driven element, one reflector, and all are the parasitic elements, and it is also called as a director. So this reflector placed behind this driven element, length of 50% longer than the driven element. It reflects energy forward side. Whatever the reflector is there, whatever the radiation is comes to this reflector, this will be reflected towards the forward direction. That is reflector do. The next one reflects the energy forward, improving the gain placed in front of the driven element. Next one is the director. Slightly, all are the directors, slightly shorter than the driven element, increase directivity and gain. Next one, performance characteristics of the antenna. The gain is 7 to 20 decibels, depends upon the number of directors. Already I told you in the Yagi-Uda antenna we are having number of arrays. The first one is reflector, the feed element is driven element, all are the parasitic elements, or we are call it as a directors. If we increase number of director more, then we can improve the gain, that is in the decibels. That's why it is called as a depends upon number of directors. Next, bandwidth. Its bandwidth is narrow to moderate. Polarization is a linear polarization. Linear polarization means it is not circular, simply linear polarization. Next one is, so what are the advantages of this Yagi-Uda antenna? Simple construction. That means it is like an array, and high gain and directivity. Its directivity is also more. If gain is more, directivity is also automatically more. Next, it is low cost, and its limitation is narrow bandwidth and physically large at low frequencies. Its design is very large, but its frequency is low. Fixed frequency operation. So these are the disadvantages. So now we need to discuss what is the main operation of Yagi-Uda antenna. I already told you that the whatever the feed line is having, that array is called as the driven element, and the behind the driven element is called as the reflector. and all are the parasitic elements. So that is called as a direct. We can call it as a directors. So what happens when the power supply is given to this driven element? This dipole element is start the radiation generation. So whatever the radiation generated by the driven element, this driven element radiation is incidenting on this all parasitic elements. Parasitic element means which is not having the feed. That means no source to it. Only driven element is having the source. So when we giving source to the transmission lines to the driven element, this driven element, this dipole is starts a radiation. This radiation will incident on this parasitic element. Parasitic element means it is not having the supply. So this whatever the radiation is generated and incidenting on these parasitic elements, these parasitic elements will excited due to the electric field in the electromagnetic waves. This electric field, it is incidenting on these parasitic elements, and this electric field will be induced into the these elements. Then the internally in every parasitic element, the electrons will try to move in the radiators. That means current flow will happen, that is induced current will be there. Then these parasitic elements are what are the reflector or directors, all these parasitic elements again try to the generate the radiation. This radiation is generated by the driven element radiation and its electrical field. When electrical field incidenting onto the parasitic elements or a reflector or driven element, these all are elements will be excited with this radiation, and due to the induced electric field into the parasitic elements, these all are try to start the generating the radiation. So what reflector will do, whatever the radiation is generated towards the last element, that is reflected, all this radiation will be, it will sends to in forward direction. It will send to the forward direction. Whatever the direction direct driven element is generated, or whatever the parasitic elements is generated, radiation is these all are tends towards one direction, that is unidirection. That's why it is called as this Yagi-Uda antenna, called as the directional antenna. Directional antenna. So this directional antenna will give high gain and high directivity. That's why its design condition is like this. The behind last one is like a large, and starting one is small size. And in the design considerations, there is some difference in the lengths. The first one, a reflector length is about 152 by its frequency in the megahertz meters. The second one, driven element length is 143 frequency in megahertz meters. And the next one that is a director length is 137 frequency in megahertz meters. Okay, here this is the formula for the lengths of reflector and driven element and director. Here if it is, for suppose this is 0.6 length, for suppose, or we can say it as if for a reflector, from the reflector length it is 10% less than the driven element, and the next to whatever the director will be there, that's length is 10% less than the driven element. If it is another parasitic element or driven element is director is, if it is installed, then it is also 10% less than the first director. If we increase more here, then for each and every array there is a difference of 10% less length. This is about the design considerations. The next one, So here we are having some advantage, that is the already I told you the simple construction. It is construction is very simple, and it is having high gain and directivity, low cost. The limitations are a narrow bandwidth, physically large at low frequencies, fixed frequency operation. Thank you.